Welcome to Section 10, Lesson 9. Square roots show up in physics, geometry, and engineering whenever a quantity scales with the square root of another. Three applications cover most of the standard cases: distance between 2 points, pendulum period, and free fall time. The distance formula is the Pythagorean theorem in disguise. The straight line distance between 2 points equals the square root of the sum of squared coordinate differences. Whenever you need a length on a coordinate plane, this is the formula. The pendulum period uses a square root of length over gravity. Doubling the length of a pendulum multiplies its period by the square root of 2, not by 2. This is the signature of a square root relationship. Free fall time also scales with a square root, this time of height. Falling from twice the height takes the square root of 2 times as long, not twice as long. The pattern repeats anytime a quantity is proportional to a square root. Doubling the input multiplies the output by root 2. The distance formula. Distance from point 1 to point 2 equals the square root of the sum of the squared x difference and the squared y difference. The right triangle on the graph shows where the formula comes from. Legs are the coordinate differences. Hypotenuse is the distance. Concrete example. Point 1 at 1, 1, point 2 at 4, 3. The triangle has legs 3 and 2, 3 units in x, 2 units in y. Plug into the formula. D equals the square root of 3 squared plus 2 squared equals the square root of 9 plus 4 equals the square root of 13. The distance is approximately 3.61. Square root of 13 is between 3 and 4 because 13 is between 9 and 16. The formula extends directly to 3 dimensions and beyond by adding more squared coordinate differences inside the radical. A pendulum's period t equals 2 pi times the square root of L over g, where L is the length and g is the gravitational acceleration. A 2.45 meter pendulum on Earth, where g is 9.8, has what period? Substitute. L equals 2.45 meters and g equals 9.8 meters per second squared. 2pi square root of 2.45 over 9.8. Simplify the inside. 2.45 divided by 9.8 equals 0.25, which is 1/4. The square root of 1/4 is 1/2. So t equals 2 pi times 1/2, which is pi. T is approximately 3.14 seconds. The graph confirms at L equals 2.45 the curve sits at t just over 3. Doubling the length to almost 5 meters would multiply the period by root 2, taking it to about 4.44 seconds. Example 2. The time t for an object to fall a height h ignoring air resistance equals the square root of 2h over g. How long does an object take to fall 80 meters on Earth? Substitute h equals 80 and g equals 9.8. Inside the radical, 2 times 80 equals 160 divided by 9.8 gives approximately 16.33. The square root of 16.33 is approximately 4.04. The fall takes about 4 seconds. The graph confirms the answer. At h equals 80 the curve sits near 4. The square root shape means falling from 160 meters takes square root of 2 times as long, about 5.71 seconds, not twice as long. Square root scaling is the signature of free fall and many other physical processes. 3 takeaways for radical applications. The distance formula equals the square root of the sum of squared coordinate differences. Applies in 2 dimensions, 3 dimensions, and any number of dimensions by adding more squared terms inside the radical. Always reduces to the Pythagorean theorem geometrically. The pendulum period is 2 pi times the square root of length over gravity. Use it for any small angle pendulum on Earth or any other planet. The square root of L means doubling the length multiplies the period by root 2, not by 2. Free fall time equals the square root of 2h over g. Doubling the height multiplies the time by root 2, not by 2. The pattern of square root scaling is the universal signature of these square root applications.